You filthy swines! Get in here, sit down, behave yourselves. We're going to read some news. I've spoken about this subject before in the past as one of my pet favourite conspiracy theories that no one seems to really talk about. And that kind of suggests to me either it's completely not true and I'm a crazy pig man, or it's very true and that's why nobody talks about it. The idea is if you could send information backwards into the past, you'd give yourself warning of any craziness that may be coming down the route. And if you were to do that, you would want that to be extremely, extremely top secret. So it sounds incredibly crazy and almost certainly not true, but it does make for interesting science fiction. And on this article from Daily Mail, written by William Hunter. The chap is still looking for Williams. He hasn't found any, poor chap. He's at wit's end. How time travel could work. Scientists have uncovered a way to send messages into the past. Blimey, really? Almost like it's true? Who knows? Time machines may seem better suited to science fiction than the physics lab, but experts say this futuristic technology could become a reality. Researchers have revealed how time travel could really work by using the laws of quantum physics. While their method won't let you hop back to the time of the dinosaurs, scientists say it could be possible to send messages into the past. The researchers even say this mind-bending technique could work just like in Christopher Nolan's sci-fi epic Interstellar. In the movie, an astronaut played by Matthew McConaughey sends a message to his daughter in the past by moving the hands on her watch. Although the reality wouldn't be so cinematic, the researchers argued that this causal loop resembles the way real-time travel would work. Co-author Dr. Haiyan Ji, a researcher at Cornell University, told New Scientist the father remembers how the daughter decodes his future messages, so he can instruct himself on what is the best way to encode the message. It might seem surprising, but there is actually nothing in the laws of physics as we understand them that makes time traveling possible. According to the laws of general relativity, which are the best description of the universe we have, everything moves through the fabric of space and time on a set path. One possible path that something can follow is known as a closed time-like curve, ETC. Something traveling on a CTC moves into the future before looping back on itself via the past to end up exactly where it started. The laws of physics allow for these loops to form, but actually making one on a large scale requires twisting space-time with a literally infinite amount of energy. That sounds impossible. However, on the very, very small scale, structures like CTs might form naturally through the laws of physics. On the quantum level, two particles can become entangled, which means that what happens to one particle affects the other even if they are light years apart. One possible way to explain this effect, which Einstein called spooky action at a distance, is to say that one particle is actually sending messages backwards in time to the other. Rather than assuming that they are part of one massive system or that they are sending information faster than light speed, the particle's sensitivity is explained by their receiving messages in the past that tell them how to react later. That might sound absolutely mad, but in 2010, scientists actually came up with a way of mimicking closed time-like curves using entangled particles. Professor Seth Lloyd, a quantum physicist from the Massachusetts Institute of Technology, says it was the equivalent of sending a photon a few nanoseconds backwards in time and having it try to kill its former self. What this creates is a bit like a telephone with a direct connection to another device a few moments earlier. In theory, you could use something like this to pass messages back to yourself in the past. Just like a real phone line, the connection on the CTC isn't always going to be perfect, and noise or disruption will make it hard to pass information with 100% accuracy. Professor Lloyd says nobody's built an actual physical closed time-like curve, and there are reasons to think it's very hard to make one, but all channels are noisy. This is where an insight from Matthew McConaughey in Interstellar comes in hand. Did say here, in Interstellar, an astronaut played by that Matthew dude sends a message to his daughter in the past by moving the hands on her watch. Since he knows how his daughter decodes the message, he can encode it in a way that makes the information legible. I thought he made books drop out of the shelf and stuff. In their new paper, accepted for publication in Physical Review Letters, Professor Lloyd and his co-authors write the father who is in the future may retrieve his memory of the past events he has witnessed, even including the daughter's decoding of the message which he is about to send. It would thus not be surprising that he will consult his memory of the daughter's decoding when encoding his message, so as to maximize the efficiency of the communication. Essentially, if you've already watched someone struggle to piece together your garbled message, you should know how to send it, so it's easier for them to decode. Even if the connection is very noisy, a backwards time-traveling message would still be legible. The slightly weird conclusion of this is that sending messages backwards in time is likely to be clearer than sending a message in normal time. Okay, why haven't you done it then? Although no one has built a real closed time-like curve, Professor Lloyd says it should be fairly easy to turn this new idea into an experiment on the quantum level. That could let scientists investigate how information is transmitted through noisy channels and even improve real-life communication methods. What is quantum entanglement? In quantum physics, entangled particles remain connected so that actions performed by one affect the behavior of the other, even if they are separated by huge distances. This means if you measure up for the spin of one photon from an entangled pair, the spin of the other measured an instant later will be down, even if the two are on opposite sides of the world. Entanglement takes place when a part of particles interact physically. For instance, a laser beam fired through a certain type of crystal can cause individual light particles to be split into pairs of entangled photons. The theory that so riled Einstein is also referred to as spooky action at a distance. Einstein wasn't happy with the theory because it suggested that information could travel faster than light. What's this say here? How to send a message back in time. Create a quantum system with two entangled particles. Go on, done that. Now what? These particles form a closed time-like curve. Wonderful. Altering one particle creates a change in the other, sending information backwards through time. If you remember how the message was decoded in the past, you can use this to change how you encode the message in the future. That allows you to send legible messages no matter how noisy the connection is. Racial cells, we've got to watch this. Hopefully the sound works and it doesn't destroy the universe. We'll find out.
Let's say you carefully prepare two particles in a lab to make them entangled. One way to set this up is to ensure that they will have opposite spins, meaning they'll line up opposite to each other in a magnetic field. Then you separate the particles by thousands of miles and measure the spin of one of them. If you find that its spin points up, the others will always point down. Like in the coin example, whenever Alice measures the spin of her particle, if it has spin up, she'll instantly know that Bob's particle has spin down, or vice versa, no matter how far away they are. Einstein called this spooky action at a distance, because according to his theory of relativity, no information can travel faster than the speed of light. You shouldn't be able to know anything about the other particle before a light beam with the information can reach you. Entanglement seems to throw this idea out the spaceship airlock. To be clear, however often it's described that way in science fiction, this is not faster than light communication.
It's not. But it is, but it's not. But it's not, but it is. I'm not entirely sure what the arc of that argument is. I know that if you accelerate matter towards the speed of light, then its relative subjective time is slowed down. So if you have entangled particles that are sent in different directions at different rates, would that not shift their relative time? And then if you could send information through those entangled particles, I've heard that that's not possible though, so I'm not exactly sure if anything here has really revealed what they're doing here, other than entangled particles send information instantaneously, and we think we can send them backwards in time. I suppose so, if you could accelerate those particles super fast and then see if you could replicate that, maybe? I don't know that. It's different to how I had imagined it, but that's interesting. I've read stories about accelerating wormholes close to relativistic speeds where they will then slow down the time for one of the openings of the wormhole, whereas the other one remains at the same rate, and then you can travel back in time through the accelerated wormhole or forward through the stationary one. I guess that's what they're going with here, but just by mucking around with entangled particles that are relativistically separated. Is that what we're doing there? Maybe. I don't know. It's very interesting. I think one of the reasons why SETI hasn't really been that successful could be because no aliens out there are actually communicating with radio waves. It's kind of like we're using smoke signals and perhaps they're using some other method, and maybe entangled particles is the way to send information faster than light. Maybe there are other ways. Maybe there are tachyons that are particles that can travel faster than the speed of light, in which case they'd actually go backwards in time. But yeah, interesting. But that could potentially be a way to solve the Fermi paradox. But that is it for now. Make sure you hit that like button. Subscribe if you can. The best place to subscribe is x.com/ultraswinery. And the only thing I have left to say is Pigwig out.
Oink, oinkity, snort, schnuffle, schnuffle, squee, oink, oink, ree, squeal, snort, snort, oinkity, squee. Oink, 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 squee, squee, ree, 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 shuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 ree, 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 snort, snuffle, oink, squee, squeal, ree, snort, oinky, oinkity, oink, oink, snuffle, ree, squee, snort, oink, squeal. Oink, 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 squee, squee, ree, 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 shuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 ree, 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 oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, ree, squee, snort, oink, squeal. Oink, 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 squee, squee, ree, 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 shuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 ree, 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 squeal, squeal. Snort, shuffle, oink, ree, squeal, ree, snort, oinky, oinkity, oink, 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 snuffle, ree, squee, snort, oink, squeal, oink, oink, oinkity, squee, squee, ree, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 ree, 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 squeal, squeal, snort, snuffle, oink.